Hello guys, welcome to my channel, and that's where I go over some concepts of math and physics and we solve some problems. So please subscribe to the channel so that you don't miss any videos. Okay, so in today's video I'm gonna go over derivatives of trigonometric functions, and I'm gonna go over some rules and some examples. Okay, and let me show you what examples I'm going to work on today to find derivative. So first of them is this one, that's where we're gonna use product rule, and then we're gonna go over this one, that's where we're gonna use quotient rule, and third one is this one, again the quotient rule. This is the fourth one, fifth one, that's where we're gonna use chain rule, and this will be our last example. All right, so let's start with our problems. So this page shows some of the standard trigonometric functions and their derivatives. So like the derivative of sine x is cosine x, and the derivative of cosine x is negative of sine x, and the derivative of tangent x is secant square x. Derivative of cotangent x is equal to negative cosecant square x, and derivative of cosecant x is cosecant x into cotangent x, and derivative of secant x is equal to secant x into tangent x. So those are the some standard functions whose derivative we can just remember, and we can use them to find the derivative of other trigonometric functions. Okay, let's start with our first example. So this is x, so y is our function is x into cosine x plus 2 times tangent x. So that's where for the first part we're gonna use the product rule. So according to product rule, let's say if you have two functions fx and gx, and you're trying to find the derivative, so their derivative is basically equal to, so first function into the derivative of second function, which is gx, plus second function, we are not going to do anything with the second function, and derivative of first function. Alright, so first function derivative of second function plus second function into derivative of first function. Alright, so let's use this rule over here and see what we can do to solve this problem. So that means dy over dx is equal to, so x is my first function, so I'm going to leave it like this. I'm going to write derivative of second function, so we are using a product rule, plus then second function, which is cosine x, and derivative of my first function. And over here 2 is constant, is out, and d over dx is derivative of tangent x. Alright, so let's solve it. So dy over dx is equal to x into, and derivative of cosine is negative sine x. Let me show you again. So standard function derivative of cosine x is negative sine x. Okay, so plus cosine x, and dx over dx gives us 1, plus 2, derivative of tangent x is secant square x. Okay, so that's our answer, that's it. So we solved one problem. Okay, so I'm going to show you this one over here again. The derivative of tangent x is secant square x. Let's go to the next problem, so which is y is equal to x over 2 minus tangent x, and we are going to find the derivative of it. So to find the derivative of function that looks like a fraction, so we're going to use a quotient rule. Okay, so this is my numerator and this is my denominator. So let's say you have function f of x over g of x, right? And we are going to find the derivative of this function. So this rule tells me, so g of x, the denominator, and derivative of numerator, which is f of x, minus numerator, which is f of x, and derivative of denominator, which is g of x over dx, over denominator square. And to remember it, what I do, I always use it like this. I'll say d over dx, the numerator is n, the denominator is d, so I'll say d denominator into derivative of numerator minus numerator into derivative of denominator over denominator square. Okay, so let's do that. So first of all, what we're gonna do, so my numerator is, I'm gonna just label it as n, and this is my d, right? So my numerator n is x and denominator is 2 minus tangent x. So what will be the, I'm gonna find their derivative and then just plug in those values over here in the quotient rule formula. Okay, so derivative of x, which is dn over dx, gives me 1, and derivative of denominator is derivative of constant, so that means there is no change in it, which is 0, minus derivative of tangent x is going to be secant square x. Okay, let's plug in those numbers over here. That means dy over dx is equal to, remember, d, which is my 2 minus tangent x, so denominator, into derivative of numerator, which is 1, we just find out, minus numerator, which is x, into derivative of denominator, which is negative secant square x. Okay, divided by square of the denominator, which is 2 minus tangent x square. So this can be written as, let's open the parenthesis, 2 minus tangent x plus x secant square x over 2 minus tangent x square. That's it, that's our answer. Done. So only thing is, just remember the rule. That way you can solve any problem related to derivatives for trigonometric function. Okay, so one more time, the rule, quotient rule, says the derivative of, let's say, numerator over denominator. So you can say denominator into derivative of numerator minus numerator and derivative of denominator and divided by square of the denominator. Okay, so let's go to the next problem, which is y is equal to tangent x minus 1 over secant x. Again, to make my life easy, what I'll do, so I'm gonna write the quotient rule here, which is denominator dn over dx minus numerator derivative of denominator over denominator square. Okay, so let's do this one. So I'm gonna say this is my numerator, that's my denominator. So let's find their derivatives. So n is basically tangent x minus 1 and d is equal to secant x. So derivative of numerator dn over dx is going to be, so derivative of tangent x is secant square x minus 0, and the derivative of secant x is secant x tangent x. Okay, so let's plug in those into this formula. So that means dy over dx, means derivative of this function, is equal to denominator, which is secant x, into derivative of numerator, which is secant square x, okay, secant square x, minus my numerator, which is tangent x minus 1, into the derivative of denominator, which is secant x into tangent x. Secant x into tangent x divided by the square of the denominator, which is secant square x. Okay, so now we found the derivative. The only thing left is we need to simplify it to make it look like a simplified function. Okay, let's do that. So we're going to use some trigonometric identities over here. So secant x, and you know secant square x is basically equal to tangent square x plus 1. Okay, minus, and what I did, I'm gonna multiply these like distribute over here. So multiply by this and multiply by 1. So this gives me secant x into tangent x multiplied by tangent x gives me secant x into tangent square x. Tangent square x minus, so secant x tangent x multiplied by 1 gives me secant x into tangent x. That's it. And we all know it's divided by secant square x. Okay, let's do next step. So like distribute this one over there and with the 1. Okay, so this gives me secant x into tangent square x. Secant x tangent square x plus secant x multiplied by 1 gives me secant x, and then we're going to distribute this negative sign. So secant x into tangent square x minus multiply minus gives me positive secant x tangent x and divide it by secant square x. Okay, now look at this. So this is positive secant x tangent square x, and this is a negative secant x tangent square x. So they'll cancel out each other, and what we left with is secant x plus secant x tangent x. So what I'm gonna do, I'm gonna take out secant x common from both of them. So secant x. So if I take secant x from here, I'm left with 1, and over here I'm left with plus tangent x, and divide it by secant square x. And see, this secant x will cancel the square over here, so we're left with the dy over dx equal to 1 plus tangent x over secant x. So that's how we can find the derivative of this function. So that's our answer. Good. Let's do next example. So this is an interesting looking example, and there are a lot of them. You can do like cosine here, you can use tangent or 1, 2, or whatever you like to do, but the rule is same. Let me go over the rule for problems that looks like this. So they ask us to find the derivative of this function. So what we're gonna do, so look at this. Each under the square root term is basically equal to a y. See, this is also a y. This is also a y. So what I'm gonna do, so y can be written as y is equal to square root of sine x plus, as this is a y, I'm just gonna replace it with y. Okay, now it's done. So now find the derivative of this function. So that's the trick, you know, each term under the square root is basically the function itself, right? So we got y is equal to square root of sine x plus, and this is again the function itself, which is y, right? So I replaced everything with the function itself, which is y, and I'm gonna find the derivative. So dy over dx. Oh, let's make it simple first. Okay, so let me do this. How about if we do square on both sides? So that'll give me y square, and square will cancel this. Square root on right hand side gives me sine x plus y. Now take the derivative. Okay, and use the power rule. So when you take the derivative, oh, let me write it down, d over dx of this and d over dx of this function over here. So derivative of y square is, and I think you all know, 2y into dy over dx. It's basically the chain rule, is equal to derivative of sine x is cosine x plus dy over dx. Therefore, and if I subtract dy over dx on both sides, so that gives me 2 by dy over dx minus dy over dx, and this will cancel out here, is equal to cosine x, right? So both of these numbers have this common factor dy over dx. So what I'm going to do, I'm going to take it out. So dy over dx, if I take dy over dx out from these two numbers, I left with the 2y, and over here I left with the 1, is equal to cosine x. So divide both sides by 2y minus 1. So that'll give me dy over dx is equal to cosine x over 2y minus 1. There you go, that's your answer. Okay, so you can use the same trick for any function over here. Let's say cosine x or tangent x. So you're going to use the same trick and solve it, and you can find the derivative of this kind of function. Okay, so that's my answer. And you can replace the y over here with the function itself if you want it to be more accurate. So, but I left it as a y because that's going to take a lot of space here. So easy. Let's do next one. So next one is basically y is equal to secant square x plus secant x tangent x. So we're going to use a chain rule and the product rule. So here we're going to use the chain rule, and for the second part we're going to use the product rule of derivative. Okay, so let's do that. So dy over dx is equal to, so secant square, so outside, so you're gonna find the derivative of outside. So you see the power over here, you know, the power comes in front of, and secant x, and 2 minus 1 is 1, and then derivative of secant x. Okay, and over here we're gonna use the chain rule, product rule. The first function derivative of second function, which is tangent x, and plus second function into the derivative of first function. Okay, so this gives me, this is going to be 2 secant x, and the derivative of secant x is secant x tangent x. That's why I ask you guys, please remember the derivatives of those standard trigonometric functions. Okay, and over here we got secant x, and the derivative of tangent x is equal to secant square x plus tangent x, and derivative of secant x again is secant x tangent x. So now we want to make this is basically the answer, but we want to make it more simplified, right? So let's do that. So let's multiply, and secant with the secant gives me secant square x tangent x, and we got over here secant cube x, and here we got tangent square x into secant x. All right, let's do more simplification. So 2 into, and secant square x can be written as 1 over cosine square x, and tangent x can be written as sine over cosine, sine over sine x over cosine x, plus secant cube x can be written as 1 over cosine cube x, and plus this tangent square x can be written as sine square x over cosine square x into, and secant x can be written as 1 over cosine x. Okay, So what we got? So we got the first term gives me 2 sine x over cosine cube x, and second term gives me 1 over cosine cube x, and third term gives me sine square x over cosine cube x. Okay, and they all have the same denominator, common denominator, which is cosine cube x. So this can be written as 1 plus sine square x plus 2 sine x. I just rearrange them because I'm going to use one formula over here. And if you all remember, a plus b square is equal to a square plus b square plus 2ab. And if you look over here carefully, this is basically 1 plus sine x square, right? So 1 plus sine x square over cosine cube x. So if we open this square, this gives me 1 square, which is 1 plus sine square x plus 2 times 1 into sine x. So, and we can stop here. That's my answer. But I want to simplify it further. Okay, so we can do one more step. So if we multiply this y, 1 minus sine x square over 1 minus sine x square. Okay, so that'll give me, so the numerator, this part will give me 1 square minus sine square x. Okay, and the bottom part will give me cosine cube x into 1 minus sine x square. Let me go over this numerator, how we get 1 square minus sine square x. Okay, so let's do that over here. Okay, so if I write a formula, so this is basically a plus b square into a minus b square. So this is 1 is my a and sine x my b. Okay, so a plus b square into a minus b square. So this is basically equal to, so a plus b 2 times, right, and a minus b also 2 times. Okay, and if I rearrange them, I'm gonna a plus b with a minus b and a plus b, a minus b. And if you see, this is basically equal to a square minus b square multiplied by another a square minus b square, which is equal to a square minus b square square over here. Okay, and that's what we are doing there. So 1 square minus sine square x square. Okay, and 1 minus sine square x, again we're going to use the trigonometric identity, which is sine square x plus cosine square x is equal to 1, and 1 minus sine square x is basically equal to cosine square x. And do not forget to put this square, this one, over cosine cube x into 1 minus sine x square. Okay, so this, the top part will give me cosine raised to power 4x, and the bottom we got cos x cube x. So we'll cancel them out. We're left with cos x in the numerator, and in the denominator we're left with 1 minus sine x square. There you go. So we can simplify it further. Okay, let's do one more, and that's the last one. So if you look at this carefully, what this one looks like, cos y is equal to x into cos of a plus y, and they ask us to find dy over dx, but we do not have y like separate, like single y here anywhere. So we're gonna play a trick over here. So we're gonna write it in terms of x. Okay, so if we divide both sides by cosine of a plus y, so that'll give me x is equal to cosine of y over cosine of a plus y. Okay, and what we're gonna do here, we are going to find dx over dy, and at the end we're gonna just flip it, and that'll give us dy over dx. All right, and in this case we're gonna use the quotient rule. Remember, the derivative of denominator into derivative of numerator minus numerator into derivative of denominator and divided by square of the denominator. So let's do that. So denominator is cosine of a plus y and d over dx of cos y, which is my numerator, minus numerator, which is cos y, and derivative of my denominator, which is cosine of a plus y, and divided by the square of denominator, which is cosine square into a plus y. Okay, so let's do it. So this is, I'm gonna write it over here, dx over dy is equal to cosine a plus y, and derivative of cosine y is minus sine y, minus cosine of y, and derivative of cosine again minus sine a plus y. Uh-oh, I made a mistake. This is d over dy, not x, d over dy. Okay, and into the chain rule formula, so derivative of dy over dy divided by the square of denominator, which was cosine square a plus y. Okay, now so let's rearrange them. So this can be written as negative cosine of a plus y into sine y plus negative multiply negative gives me plus cosine y into sine of a plus y, and dy over dy is 1 divided by cosine square into a plus y. Okay, so we're gonna use one more trigonometric identity over here. I'll show you. Let's rearrange the numerator one more time. So can be written as cosine y, or sorry, so I'm gonna write sine a plus y into cosine y, which is this term, minus, now this term, cos of a plus y into sine y, and divided by cosine square of a plus y. Okay, so the trigonometric identity I'm going to use is going to be, you all know maybe or no, but remember, sine of a minus b is equal to sine a cos b minus cos a into sine b. And if we look carefully, this is basically, that's what we got over here. So this is my a and this is my b. Okay, so the numerator can be written as sine of a minus b, and a over here is a plus y minus b is my y, that's it, and divided by cosine square a plus y. Okay, and y cancel out, and this gives me sine of a over cosine square a plus y. Okay, so this is my dx over dy. But we need to find dy over dx. So just flip it. So dy over dx basically equal to 1 over dx over dy. Can be written as, so we're gonna flip this. This becomes cosine square a plus y over sine a. So that's my answer. All right, so we did few examples today, guys. So what I'll ask you to practice more examples. Okay, just watch this video and learn few tricks, but please do practice by yourself too. And remember the derivative of standard trigonometric functions and some trigonometric identities. Okay, I hope this will help you all. Please share and subscribe to this channel so that you can watch more videos. And thanks for watching. Have a good day. Bye bye.